Okay, this is the homework help video for Honors Math 3, Unit 9, Objective 7. So we are going to look at trying to simplify using identities. So the identity that we're going to be working with is 2 sine theta. Cosine theta is equal to sine of 2 theta. And then we also snuck in a review one of the Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1. So we snuck 1 or 2 of those into your homework as well. It's just a really good review for you. Okay, so let's go ahead and take a look at question number 6. So I have to figure out, okay, well, what identity does that look like? So I have a product of sine and cosine with the same angle, right? So a product of sine and cosine with the same angle, and that angle being pi over 8, right? So I have a product of sine and cosine with that angle being the same of pi over 8. So that means I'm going to be using this identity right here, but in order to do that I have to have a 2 in front, right? I have to have a 2 in front. So I can't just randomly place a 2. I need to, keep that kind of product consistent here. And so in order for me to do that, I'm going to go ahead and put a 2 in front, but if I multiply by 2, I need to divide by 2 as well, and dividing by 2 is the same as multiplying by half. So 1/2 times 2 is 1, which is the same as what is there. And then the rest of that is going to stay the same. So then now this part right here mirrors this portion here, right? So these are equivalent to each other than theta, which is just pi over 8. So then if I have that, oh, I just realized this looks like a squared. That should be just a 2, not a squared. That should be just sine 2 theta, not a squared. Okay, so then I know I can use that identity. So that 1/2 is just going to carry down. And then all of this is going to swap out and replace with sine of 2 times theta, right? Because these are equal to each other. So if I have a product of sine and cosine that's being doubled, I can replace all 3 of those things with sine of 2 times theta. So then all of that is going to replace with sine of 2, and then theta is just my angle, which is pi over 8. And I'm going to put that over 1. So then I can say 2 goes into 2 once and into 8 4 times. So I would just have 1 times pi over 4 or pi over 4. So this actually happens to be something I can simplify, right? Because sine of pi over 4 is a value I know in the unit circle. And so that would be 1/2, and then sine would be root 2 over 2 at pi over 4. So that would just be square root of 2 over 4. So 1 times root 2 is root 2, and 2 times 2 is 4. So then I can actually simplify that a little bit further than usual, right? Okay. And then question number 10. So this is when we kind of snuck in. So I don't have a product of sine and cosine, but I have a sum of their squares, right? And then I have the same angle. So then that means I'm going to be actually just using good old-fashioned Pythagorean theorem, which we all know and love. So even though the sine and the cosine are reversed in their order, that does not matter, right? And that's because addition is commutative, right? So it doesn't matter which way I add them, I'll still end up with the same result. And so these are the same angle, so then that is just going to turn into 1. All right, and then one more, number 25. So for question number 25, so I have a product of sine and cosine with the same angle, and that angle for this one is 40 degrees, right? So again, in order for this to be used as an identity, I need that 4 right here to actually be a 2. So I'm going to just break up that 4 to be 2 times 2. And then I have the identity right here, right? So then I have that identity format, the product of sine and cosine with matching angles, that's being doubled. So this 2 is still going to be here, right? This one right here. And then this is my identity, so that's going to be replaced with sine of 2 times theta, which was 40 degrees. And so that would just be 2 times the sine of 80. And then 80 degrees is not a value I know, so then that would be the farthest I can go to simplify that. And that's it.